morning, sir.
Tell me, what day is it?
What day?
Goddamn Christmas!
Hey everybody, it's Jay Hersko from the Agile Uprising podcast. Wanted to give a quick update to everyone as to what's going on in our neck of the woods. So first of all, some bad news. We are not going to be doing new episodes this week or next. The team is taking a well-deserved 2-week rest as we retool, regroup, recharge, and try and enjoy the holidays with our families. So apologies if you were looking forward to some new content. But again, we need to take a little bit of time off just to get ourselves together so we can continue to keep bringing you all the content that you love, hopefully. In lieu of a new episode, we are going to be rebroadcasting a previous episode we did, one of our most listened to episodes. It was an interview with Fowler and Rebecca Wirfs-Bock, and the subject was Agile Architecture. So enjoy the rebroadcast. But before we get to that, a couple of notes. So upcoming in 2019, wanted to give all of our listeners a preview as to some of the things we've got working in the kitchen. So one of the things we are going to continue doing is we are going to continue doing Ask Me Anythings on the Coalition site, but we are also going to tie them to a podcast episode where any questions you submit ahead of time, we will be answering in live form on the podcast. So we have a couple of guests lined up. We have a couple of surprises, which I think everybody will enjoy. If you have someone you think you would like to be a guest, if there's someone you really want to hear from, please go on to the coalition.agileuprising.com and let us know, and we'll do our best to network and see who we can get on. Also, we are going to do a series coming up probably in the early spring on transformations from the trenches. What we're trying to do is find people who are in organizations currently going through an agile transformation, an agile adoption, and we're going to try and rope them into, have them talk about what's been good for them, what hasn't, what would they change, what would they have coached differently, and we're going to try and concentrate on not getting so much coaches, but we would really like to get executives. We'd like to get people who are not agilists by trade and see what their, from the outside looking in, approach is, and what their opinions are on how successful we are, what their transformation journey has been like. So maybe we can all learn something about the people who don't do this day in and day out. Also, the next big project we have coming up is the game of frameworks. We've talked a lot about scaling on this podcast. We talk a lot about SAFe, but we really don't give any love to any of the other frameworks. So what we're going to try and do is round up some authors, some creators, some people who have come up with frameworks of their own or experienced in other frameworks to come in and give 2 cents on things like Nexus, on things like Scrum at Scale, DAD, LESS, you name it. Because we think that here at the Agile Uprising, we think that the future is truly going to be something where you just grab the pieces that work the best. So we want to help educate people and get some insight into some of these frameworks that may not be as used so much in the workplace. So looking forward to that. Hope everybody enjoys it. And last but not least, we want to offer a solemn condolences and remembrance for anyone who has lost family, friends, or loved ones this year. As you may or may not be aware, we did lose Mike Beadle earlier this year. So we wanted to offer our condolences to his family and to anyone who's lost a loved one this past year. We offer our sincerest sympathies. With that being said, enjoy the episode, and we will see you again in 2019.
This is Joshua Karievsky. You are listening to the Agile Uprising podcast.
Hello and welcome to the next edition of the Agile Uprising podcast. Today I am joined by the one and only Rebecca Wirfs-Bock and the one and only Martin Fowler. Thank you guys for coming on today.
Hey, thanks.
Thank you.
For those that don't know, Rebecca is one of the original thought leaders in the object-oriented world. All of the X-driven design frameworks are generally accredited to her, and she's a great resource when it comes to talking about Agile, talking about architecture, talking about object-oriented languages and the convergence of all of those. So welcome, Rebecca. And Martin, this is your second time, so you didn't have enough fun the first time. You came back for some more.
Yeah, and I should say, I mean, Rebecca was one of my she taught me a lot through her books and writings when I was just getting started in this. So It's always good to collaborate with her.
Yeah, likewise.
So I guess today we're coming together and we want to talk about Agile architecture. And as is the case with most things, it's usually good to define the thing before you talk about the thing. So we'll skip over the Agile part because I imagine if you found your way to the podcast, you have enough of an understanding of where we're going with that. But when we talk about architecture, I guess, how would you define it, Martin? I know you have some strong feelings on what it is. Can you just frame out the concept?
Yeah, well, the approach that I tend to use for describing architecture is actually one that I wrote down quite a while ago. I used to write the design column for IEEE software, and there's one of those called "Who Needs an Architect?" And in that, I really went through my thinking of what an architecture was, because obviously you need to define architecture before you talk about the role of an architect. And actually, it wasn't me. Because actually most of that column is quoting Ralph Johnson. He replied on an email thread on a mailing list, a really good summary of his thoughts about what architecture was, and basically I just nicked them because I like pinching from the best. And there's really a couple, I guess there's a couple of common threads by which people have often described architecture. And so one of them is to say, it's the most significant or top-level components in a system and how they're wired together, what their interfaces are, what their connections and things of that kind. And that has found its way into an IEEE standard and a couple of other places. And Ralph's big objection to this was, well, what makes a component significant? What makes it top-level? How do we come up with that, sort of hand-wavy statement of it? And he dug into that a little bit further by saying, well, really what it is, it's the developers, in particular the lead developers, the expert developers on the team, it's their judgment that something is significant or top level. And really what an architecture is in that sense is it's the shared understanding of the leading developers on the team. And this is really quite important, of course, because this reinforces the fact that it's very much a social construct, which I think is a really good one. Now, there's another style of definition as well, which is often talked about for architecture, and that is that it's the set of design decisions that you need to get right early on in the project. And Ralph complained about that one as well and said, well, really that is saying it's the ones that you wish you could get right early in a project, because you're not necessarily going to get them more right than you are any other set of decisions. But in many ways, we can boil these together with the rather flip statement, or at least it sounds initially a flip statement, which he ended up summarizing with, is architecture is the important stuff, whatever that happens to be. And as I said, that sounds kind of flip, but actually, I think it's one of those statements that actually has a lot going for it, because it immediately says that one of the key architectural decisions is actually figuring out what is the important stuff. What should we be caring about? And so that tends to be my touch point for architecture. It is what is the stuff that we consider to be the most important for a project or for a system more broadly.
Great. Rebecca, is there anything that you would add to the common definition of architecture?
Well, so when you talk about decisions, I'm going to add this other riff on this about agility, in that we like to say in the Agile world that we don't want to do things too early in the game. So I think when you talk about Agile architecture, it's timely decision-making backed up by evidence. So it isn't speculation about what's important. It's got to be evidence-based. And I think that's a distinguishing characteristic of an Agile approach to it versus, pie in the sky kind of approaches.
Yeah, I love the way you put that. And I think we'll probably dig into that a little bit as we go through here today. I guess for anybody that's listening and they're still trying to figure out when we talk about architecture, I mean, one thing that I kind of look towards as kind of this is what I consider to obviously be architecture, is when you start a new project, you start talking about database schemas and things like that. I mean, is that, if we're going to look for something that we can point to and say, yes, that is part of architecture, is that one that we can agree with on this conversation?
No, not really.
Perfect.
I would say that it depends on the software system you're working with.
Right.
In fact, Ralph actually used this as one of his examples. He said that, for typical enterprise applications, which is what I take it you're familiar with, and indeed what I'm familiar with, well, yes, getting database is always a big issue. And whenever you see someone on that kind of project draw an architecture diagram, usually it's a bunch of layers with database being a big prominent part of it. Mm-hmm. But as Ralph pointed out, if I'm building a system that's all about processing medical images and trying to do sequence processing on that, the database is just where I get the image from. It's not actually important to me. And so it becomes a secondary concern. It really depends on the kind of system I'm working with as to whether the database becomes an architecture or not, whether it's important or not. Cool.
Well, I've already knocked out the Ryan gets something wrong part of the interview, so that's good to get that out early. So let's, if you don't mind, let's shift then into, let's put ourselves into the mindset of building out some type of greenfield architecture in that agile fashion. How do we first start approaching that design?
If I'm trying to do something that I've already done before, like a Rails app, and I'm just using that as an example, and I know what I'm doing, there may not be much architecture on that greenfield project at all. It's use these libraries, here we go. But if I'm doing something really new and novel that I don't know how to build, then I get involved with the things that I want to discover before I commit to them.
So then I guess to paraphrase, you come into a new effort with all of the empirical learning that you've had up to that point, and you're applying that against the problems that you're looking to solve. You're separating out the areas of low risk because of known exposure, things that you've been through before. You're pushing that aside and you're saying, okay, here are the things I know I don't know. Let's start running some experiments and let's gain some quick learning. Yeah,
and that's my general approach to almost anything. It may not be, I'm going to say a popular approach, but if I think something is, I just don't know the hell how to do it, then I need to do something about getting some learning about that. So it isn't just, now, hopefully I'm picking the things that are going to be delivering value as well, but it isn't just banging out the easy stuff.
Mm-hmm. Martin, when you're approaching a similar situation, what are there any patterns that you tend to follow when you're just getting started? Like, how do you wrap your head around these relatively large, complex things that we want to try to get, to your point, or to Ralph's point, you want to get right up front?
Yeah, thinking about in terms of risk, the things that can go wrong, exploring ways to deal with that, absolutely the case. And it's certainly true that a lot of organizations are very reluctant to write code knowing they're going to throw it away, which is a shame, because often the best way to explore a problem is to build it 2 or 3 different ways, knowing that you're going to throw n-1 of them away, and possibly even n if you find out that what you've learned is that you need to actually take another path. And people are sadly reluctant to do that.
Yeah, and I think it's because, and I'm going to say, I think agility has had an impact on that, because essentially it's saying, well, I can incrementally deliver and I can incrementally pivot and change, and so let's just keep rolling along rather than, let's throw something away and do it again. Of course, people do that throwing away very often, but sometimes if they're involved in larger projects or programs where I get involved, that's almost heresy to mention that we should throw this away and start again.
So why do you guys think that is? Because I experience that all the time. As soon as you start writing code, it's basically chiseled in granite, and that is the solution. Why do you think there's an adverse reaction to that concept of experimenting and not every experiment passes?
Well, I guess it comes down to people valuing the code rather than the learning you get from writing it, and not understanding the degree to which actually developing some code and developing a solution is such a large part of learning about this kind of stuff. It's always been a source of great frustration for me, because I do very much feel there is a role for that, experimenting and sketching and trying things out. And whenever I'm approaching a problem, even on a small scale, my first guess at what I think is the right approach usually isn't, well, always isn't 100% right. I always have to adapt it as I learn and try things out. And that's also part of my learning approach. I learn things by doing them, and I think a lot of us do.
So it's interesting that Don Wells, on his XP site about XP, he talks about design spikes. And had a definition from long ago about what a design spike is. It's like, well, I may spend a few hours discovering something and exploring something that I don't know, with the intent of throwing it away afterwards. And that kind of XP value seemed to have been gotten lost, I would say.
So I love that you brought in XP because, well, first of all, because of the audience I'm speaking with right here, but also, if we're doing this as in an experimental fashion, where we're doing that separation of concerns, we're bringing the risky unknowns into the forefront, and we're going in with the understanding that there's a chance that we throw away a couple of these experiments. Do we build those experiments out, or do we build those early prototypes out following the patterns that we would build for code that we expect to see the light of day? Are we building in the test? Are we going through and doing the all of the best practices, following the principles that we believe in for production-ready code when we know it's just an experiment?
I don't think so. Personally, when I want to do an experiment, and I do this, I tend to write just the slimmest bit of code to prove out something or my understanding of something, and then it's almost like, okay, I've got it, then I need to fill it out. And so I don't even necessarily want to go through all the steps of, that cycle of, robust unit tests, because I'm trying to do a slice through it to understand. So I wouldn't necessarily, I think that's the difference between a prototype or a design concept versus something that is more robust.
Mm-hmm.
Yeah, and I agree, but with the caveat that sometimes I go faster even in prototyping mode by doing a few tests.
A few, but I might do more.
Yeah, I mean, it's really, you're certainly sacrificing long-term or even medium-term maintainability for speed, because you want to learn as much as possible as fast as you can. So you alter your practices to maximize that, as opposed to I'm going to be coming back and modifying this code in a year's time. So I have to bear that in mind. So you tilt your practices appropriately for that.
So I guess the next question I really have is really around the idea of upfront design, which I've seen debated more, well, as much as the conversation around throwaway code. What is the right amount of upfront design that should be done when we're talking about architecture, we're jumping into a new endeavor or some type of new product that we plan to build out?
Well, to approach that one, I want to introduce another idea. And this also goes back to that IEEE comment, where I said, one of my headings says, getting rid of software architecture. And I often say the best thing an architect can do is get rid of as much architecture as possible. And the logic here is, if we go back to that original statement that came from Ralph Johnson, where he said a common statement was architecture is the decisions that you wish you could get right early in a project. Why is it we want to get decisions right early in a project? Well, because we perceive them as hard to change. So that leads to actually one of the more useful rules of thumb about what is architectural, what is important, which is things that are difficult to change. But it also raises another question, is, well, can you actually make progress by making things easy to change? And a great example of this is actually the one you came up with just a moment ago, database scheme. Right? Back in 2000, database schemas were absolutely considered to be architectural. If you don't get your database schema right, and you don't get it right at the beginning, you're going to be stuffed. So you have to put the effort to get it right. And I was working on a project like that, and my colleague, promotes at Algae, who was the database administrator on that project, approached the problem differently. He said, well, why do we have to make these things hard to change? How do we figure out how to make this stuff easy to change? And so he came up with the whole approach of database migrations that you see in tools now like Liquibase and Rails migrations and the like, that made database schemas straightforward to change. And so, at least for us, for the last decade, database schemas are not architectural, because we evolve them as the project goes on, even if it's been deployed to live and all the rest of it, because we know how to migrate. And so that is one thing that's really quite important when you're thinking of what do we need to get right up front. Another thing pertains, I think, to Rebecca's point. If you have a system that matches fairly well with the framework you've already got, like, say, Rails, you say, okay, I'm going to use their architecture. And then a whole load of decisions are made for you. Yep. And as long as you're within the ballpark of what that kind of framework works well for, then that's cool. So I think it really boils down to this question of what's difficult to change, coupled with the notion that it's always better to try and find a way to make it easy to change than it is to decide up front what the right thing is.
One of the interesting things to think about understanding what is easier to change or not is the notion of shearing layers. And in the Big Ball of Mud paper that Brian Foote and Joe Yoder wrote about, they mentioned the notion of software sharing layers. They were inspired in that Big Ball of Mud, which is not an anti-pattern, but it's how to keep legacy systems working despite a lot of clutter and things that don't necessarily fit together well. They were inspired by Stuart Brand's book on how buildings learn. And he wrote about different layers in a building, the platform, the skin, the structural parts, and all the way to the guts and the services layer and the stuff inside of a building, and says that we need to isolate things that change more rapidly from things that do change. And that same notion applies to the way we structure software. Now, if we don't know what's going to change, then we don't know what to isolate, right? But if we do understand the rates of change in our software systems, a lot of libraries and frameworks take that into account. So they provide that insulation layer between the particulars of a database, for example, and access to that database. And so just sort of understanding the rates of what's going to change and designing so that I can let the things that change, that are going to be changing with my software, change more readily is a really important thing to do, whether it's using tools or just how I structure things.
So at the risk of getting burned in the stove again, and that's the beautiful thing about a podcast, I can edit this out if I'm completely wrong. Are there tried and true examples of things that we generally accept are not going to change when we approach a project? Is there something that it rings true with nearly 80% of the projects that this is something that we're pretty confident is not going to change that dynamically, and we can build our architecture based off that understanding? I see you smiling already that you're going to blast me.
Very few things really don't change. Ironically, one of them that is often the thing that doesn't change, that is almost no one considers to be an architectural decision, is the main programming language the project uses. Very rarely do people describe that as part of their architecture. But and this I think is one of the key things that makes Agile architecture interesting, is it's really about saying how do we make and control and live with change. Just as that's true with agility in software projects generally, that's absolutely the case in what we're doing. At the moment, two of my colleagues, Neil Ford and Rebecca Parsons, they're just wrapping up their first draft of a book on evolutionary architecture, which I was hoping to have read before this podcast, but they haven't given it to me yet. Which really is trying to say architecture is all about trying to build this kind of evolution, everything could change approach, while at the same time realizing that you can't make things flexible, everything flexible to change, because that adds complexity. So you're always in this balancing act between you want to support change, change is fundamentally unpredictable, but at the same time you don't want to put in too many mechanisms for flexibility because they add complexity and thus reduce changeability. It's a complicated dance, but at the heart of it, I think, is the notion that everything does evolve.
And I guess the thing is to understand the rates of change, not just that everything needs to be infinitely flexible. So if something can be changed dynamically through rereading or refreshing a configuration file, that's that sounds, that's an approach. Whereas if something needs to dynamically change its rules based on context, it's just how much do things need to change? A lot of enterprise software that I spend time consulting with is particularly about the mechanisms we want to use for this kinds of change that we've been seeing over time, and those are not always easy decisions, but until you see something change, you don't know the rates of what it's going to change and how best to approach it. That's where I think design patterns, having some of those in your back pocket, if you will, as well as understanding basic techniques for configuring and making things be flexible without having to rewrite code, although even writing new code isn't that difficult if we have a good deployment environment. There's just so many ways that you can make things change. The question is, who's going to make those changes and what do they have to know in order to make those changes?
Yeah, and I'm glad I actually took the risk, because I was asking that question from an absolutely ignorant perspective. I could not come up in my head, as you guys were both describing, things that change versus things that don't change when approaching architecture. In my mind, it was really hard for me to come up with an understanding of what would not change. Giving context, the application I live and breathe in right now is a 17-year-old legacy app. So the architecture, while there are many parts of it I would like to change, it damn sure is not easy. So one thing that's interesting to me, as I was preparing for this interview, I was contacted by one of my peers, and I asked him if he had anything he wanted me to bring up, and he pointed to an interview Bob Martin did with James Copeland, and it was around the idea of upfront architecture and design. And I hate doing this, but I'm just going to read real quickly the quote that I have here. It's one of the more insidious and persistent myths of agile development is that upfront architecture and design are bad, that you should never spend time upfront making architectural decisions, that instead you should evolve your architecture and design from nothing, one test case at a time. Pardon me, but that's horseshit. I'm curious how you guys react to Bob's words there.
Are those Bob's words or Cope's words?
I believe it's Bob's, but either way, Bob or Cope's.
I'm guessing that it's Copeland's and not Bob's.
So, how do you guys feel about that? Is that something that you that resonates with you, or is that something that kind of interferes with the way that you think?
Well, if you take it to the limit, then yes, clearly, there's absolutely zero upfront thinking is horseshit. But we're not talking about taking it to that level of extreme. We're trying to say, okay, where along the dial do you try and draw it? Mm-hmm. And my view is you've just got to be very wary of upfront decisions, because those are decisions you're making with the least knowledge that you're ever going to have about the circumstances you're in. So this is where I think a useful principle is the principle of, you want to make these decisions at the last responsible moment, mm-hmm. which isn't the last moment, it's the last responsible moment.
And I would like to call that I think if you take that to extremes, that's the last irresponsible moment. And so I've actually written a blog post about this a few years back that talks about my preferred way of thinking about it is the most responsible moment. And I know I'm imperfect. I'm dealing with gut feel, heuristics, or whatever. But when I get a little anxious, then I want to make that decision. That I want to be evidence-based in what I do. I don't want to speculate. And so if you think about last responsible moment, some people are pretty irresponsible, so they wait too long. And some people are like, over planners for like my husband when he goes on a trip. He wants to get to the airport hours ahead, and I don't. So I actually think, sometimes it's the team or project culture too that determines what are those responsible moments. And decisions get stale. You wait, technology changes, my understanding of how to apply a particular framework, what I want to do, it changes. So not all decisions are, irreversible, but those that are kind of harder to pivot on are the ones that you want to do it when there's this, oh man, I think we need to decide now. Let's do some experiments and then take a path.
Yeah, I think
there's a corollary to this that's easily forgotten, which is often one of the best architectural decisions you can do, is to do something that pushes that most responsible moment back in time, forward in time, so it's later.
Forward in time, yeah.
Yeah, because if I can do something that means I don't have to make this decision for another 6 months, that may be a very good thing to do, because then I'll have 6 months more information to go on. So that can sometimes be a useful thing to bear in mind as well.
Yeah, that's perfect. I was actually gonna point out the work that Mary Poppendieck has done when she talks about the principles of lean software development. She encapsulates this whole conversation that we're having about the last responsible moment as the deferring commitment principle. And in there, she talks about exactly what you're saying, that we're constantly learning, and that there's in software we tend to say there's reversible and irreversible decisions, and technically nothing's irreversible, I guess, in technology, but it's that there's extremely painful decisions then. And
I guess the painfulness is the thing that you have to think about, because the pain point for me is probably different if I'm working on a small team than if I'm working on a larger team. Sometimes you have to make decisions so that people can just move ahead.
And that leads us, I think, to perhaps one of the most important aspects of architectural decision-making is the human part of it. One of the biggest architectural decisions a team will ever make is how to divide itself up into sub-teams, particularly for larger projects. Mm-hmm. And here, of course, one of the dominant features is Conway's law. That the architecture of your system will mirror the communication organization of the people who build it. I always love a beautiful story that was told me by an old friend of ours, Ron Crocker, when he was doing a big project, and it was one of these huge systems, and he had to assemble who he could find in this big multinational company, and he ended up starting this project with 6 teams in 6 countries, scattered across the world. And he said, my first architectural decision is that there's going to be 6 major components in this system. Don't know what they're going to be, but there's going to be 6 of them. And that was recognition that Conway's law was going to win, and he wasn't going to be able to beat it. And then, of course, you get those nice variations, like a lot of the microservices people often talk about how they will divide their people into these small teams that are customer focused, with loose communications with them, and that will force the system to go into that kind of approach, where you kind of not just recognizing that Conway's law is always going to win, but actually saying, well, I'm actually going to organize the people first, knowing that will drive the system design. And I think that's definitely not to be underestimated, is the importance, particularly for larger projects. If you've only got 4 people, then obviously this is not such a big factor. But as you move into the larger sizes, then deciding your team structure will drive your architecture, whether you like it or not. Yeah,
and I've actually encountered people who've kind of rubbed against us and sort of ignored this. They started out and with a large team structure, and they had people who knew components and were experts in that. And they said, oh, no, let's just reorganize people so that they work on features. And so nobody owned or had deep knowledge anymore of the components, and they were actually pretty technical bits involved in there. And they kind of lost something when they went to a feature organization that cut through all of those services. And so not to say that feature teams is a good thing or a bad thing, but that was kind of ignoring the architecture that was there and the expertise to keep it going.
So let me ask a question similar to the code quote that we were just talking through is, what about the concept of architecture emerging from unit tests without going to the extreme of your architecture is defined by your unit test? Because as you just mentioned and visually laid out for me the idea of Conway's law impacting architecture, how much do you allow unit testing to influence what the architecture is? And how do you apply that? Well,
so one thing, when you hear the word unit, some people may think it's a class or a function. But if I'm talking about services or components, again, that's, the unit of my understanding of using the interface of something can define a lot about the architecture. I think that one of the actually hallmarks of Agile architecture is that you think about how are you going to test it. The testability of the system as a whole, as well as individual units, whatever their size is a driving factor. And so I tend to think that another way I like to say it is that the testing strategy does determine your, some of the finer points of your architecture. That's absolutely important to think about that.
Yeah, we did an interview with David Bernstein. We talked about the intent of unit testing, and I think that was a meaningful conversation because you're not expressly trying to test every aspect or every element within the code. You're meaning to test the intent of the code itself, the behavior therein. So I think that complements with what you were saying there, Rebecca.
Mm-hmm. I agree.
Cool. So switching into the concept of domain models, when we talk about a domain model, do you guys have a leaning if there's a weighting towards doing domain modeling upfront, if that also becomes emergent with learning? And I guess the secondary question there is, who's involved in defining a domain model? Does the business get pulled into that? Is that purely a tech discussion? Do we actually have clients or potential clients, client proxies in the conversation? How do you guys approach that with new projects?
My preference is to, absolutely business, or certainly domain experts should be involved in the domain modeling, because the whole point is to create what the domain-driven design refers to as a ubiquitous language, a language by which we can communicate business people that flows into the code. So you have to have them involved, both for their knowledge and so that whatever you build in the domain model can cross into technical and business lines. And it's been a long time since I've done it, but I've certainly had a good success doing that. The other thing is, it is good, I think, to have a sketch up front to start from and kind of sketch out how you think the landscape goes, but you should absolutely expect it to change and evolve. I think Eric Evans points out that you don't really understand what your domain looks like until about a year after you've started building the software.
I think that the fact that we have the myth that the domain model is static is kind of another myth to think about. I've been working with a client for 5 years, and it wasn't that the business experts had the language that we were plucking out of the air. We were trying to create a language that used some common terminology, but there were gaps there because there weren't concepts in what they were trying to do with the system. It's truly doing new things. But now, after 3 or 4 years in the market, the domain is changing. So I tend to think that early conceptualization gets you going, and then you learn just like everything else.
Absolutely.
I'm so happy to hear you say that it's a firm requirement to have business folks involved in that domain discussion, because I've seen quite a few projects or quite a few products that have been built out without that involvement. And, oftentimes we think if we have technologists building out the domain model, we're going to have a better outcome because we're technical people. And what you end up building is the world's most over-engineered sailboat, right?
Exactly. And that's always, actually, I mean, it's kind of one of the sad things of where my career has gone more into the sort of writing side. Actually, always my favorite part of the job was working with domain experts on domain models. I mean, it's always, you can really deeply figure out how finances work, how healthcare works, all sorts of different aspects of how the world works. And you absolutely have to have the domain experts in there. And they can understand it, no doubt about it. I've worked with doctors, I've worked with accountants, I've worked with traders. It certainly can be done. But you really do need that involvement to come up with anything worthwhile.
That's great.
Yeah, I've done domain modeling too. It's funny, talking about backing into, don't box me in. We're talking about modeling with business experts and modeling and architecting with technical folks. I tend to think that in really understanding systems, you have to go kind of both ways. And it isn't just all technology, nor is it just all the domain, conceptual model either.
So I guess that kind of gracefully leads into the next area that I kind of want to touch in is just documentation. I mean, Martin, 16 of your friends and yourself went through and documented out the rules of software development that we've been following for a little while, and documentation seems to be a hotbed topic. So when we're talking specifically about architecture, what level of documentation would you expect there to be, especially early on in a product's lifecycle? And then ongoing, what would you expect there to be for minimal documentation as it pertains to describing the architecture of the system?
I don't have a particular standard. I mean, the question is, do the lead people involved in the software effort all have a shared understanding? Do we have a good shared understanding of what's going on? Now, documentation can certainly help with that. But it really depends on the team as to what extent it plays. Obviously, the larger a team tends to require more documentation. If you've got a team that's distributed across distance, that tends to require a bit more. But exactly what form it should take really depends on what the team's needs are. And again, this question of what is important. So I'm very reluctant to put down any hard and fast rules on these things.
So I actually have been working quite a bit lately with various teams on what's an appropriate level of documentation, because they actually feel like they swung a bit too far into the tests are the documentation, and they need to swing back a little bit, towards having some kind of documentation. And one of the things that comes to mind about documentation these days is that, you have to understand who the stakeholders are. Is it the development team? Is it the people that are supporting it in the field? Is it people that are product owners that are trying to make decisions later on how to make changes? And then it really does vary on what you need. But I'm just going to say there are a couple of things that I think are good to document. And there's actually a GitHub a project there about that, is to document design decisions. And Michael Nygaard has come up with one of the forms of documenting decisions that says, here's what the decision is, here's what it impacts, Does it supersede another decision or not? It's a sort of a mini pattern form of documenting decisions. And then just having something that gets you an orientation about the principles that you've followed or trying to do. And it is, that kind of the stuff that I could only get by talking to someone who was there rather than just the code. So those are the kinds of things that people really need to see, I think.
And we should also, a common refrain in the Agile community is that the source code is the documentation. And there is a lot of truth to that, but that cuts in different ways. One of the ways it cuts that people can miss as a corollary of it is, since it is the sort of primary documentation, it means you've got to put the effort in to make sure that it's good and clear. So that's why it's important that your code be clear, that it be well structured and factored nicely into good modules and all the rest of it. Major part of the reason for doing that is because it is so much the primary documentation. It also means that you should look for ways to pull other documentation based on the source code. So you often come across teams that will find, can we look at how components are communicating together? Can we extract this information from the code and plot it using automated things that will pull information out of the code? Those are great mechanisms. But also remember Grady Bucci's great phrase is the code is the truth, but not the whole truth. So that's where you add the additional items, and then you've always got to say, okay, what's the code missing? And this is where I absolutely agree with Rebecca's point about decisions. How do we document decisions? Because they often don't find their way into the code.
And actually, sometimes use cases or important use cases that you considered, going back to that are proving out the architecture are interesting things to describe too. So yeah, you can get tools to generate things from your code, given that you do consistent naming. I'll just mention one that is sort of an interesting tool that Simon Brown has been working on called Structurizer that allows you to write stuff that can then pick out and then draw those diagrams for you from your code. So that's actually you can go that route, assuming that you have reasonably structured code with consistent naming and stuff. But with legacy systems, it's probably not going to work for you.
Yeah, and also it brings in the point as well that one of the important parts of documentation is knowing what to leave out. And this is particularly true when you are pulling stuff out of the code. Well, it's actually true generally. If you're trying to, one great tool for visualizing how multiple things, objects, components, or whatever collaborate is sequence diagrams, because they can give a very nice visual picture of what's going on. But if you try to pull a sequence diagram out of code, it's a complete mess. What you have to do is decide, well, what are the important interactions? What are the important parts of what's going on? As well as deciding, well, what are the important mechanisms that are worth documenting in the first place? That's a human decision. And it goes back to the architecture, it's the important stuff thing that we mentioned earlier on. So a large part of the actual documentation decision-making is saying, well, which bits do we want to do this special treatment on, and which bits do we not? The catchphrase I like to say is, completeness is the enemy of comprehensibility.
Well, so that's a good way of thinking about it. I think that there's this, imagine this Venn diagram of all the things you could describe in documentation, you as someone with an architecture role, all the stuff that people are interested in, and hopefully what you document is in that intersection point, that it overlaps. And that's the best you can hope for. And certainly I think that sometimes we're going to err on the side of not describing the important bits. And that's why I actually have used the technique of someone new to a system who wants to understand it and starts drawing pictures or coming up with descriptions. I say, okay, you can document that. And that actually is a good approach, is getting someone new who's really eager to know about the system, because they'll remember or discover things that you have forgotten that are important.
Love it. So I'm minding my time. I think we could do a whole nother hour talking about legacy systems and the impact of architecture and lack of architectural definition in legacy systems, and probably another hour yet again on the shared role of architect on Agile teams. But I want to thank you guys for your time. Martin, what is the best way for listeners to find you, read your latest writings or any events that you may have coming up?
Go to my website, martinfowler.com. On Twitter, I announce what I do. My handle is Martin Fowler. Thank you. And then Rebecca, same?
Again, Wirfs-Bock.com. I have /resources. There's a lot of design columns that I've written that are accessible there. I also have a blog there. Two things that I am doing in the near future are giving a talk at the Agile Conference on Intentional Architecture and some practices for specifying and measuring quality. So I'm doing a couple of presentations at the upcoming Agile Conference.
Awesome. That's the Agile Alliance Conference down in Orlando?
Yes, right, in August. Mm-hmm.
Awesome. And I feel embarrassed to now drop my credentials after YouTube, but I'll do it. So I'm Ryan Lockard. I can be found on Twitter at AgilePHL. And I'm also all over the Agile Uprising Coalition, where you can find this interview posted, as well as Martin's previous interview and a whole bunch of other great content. So Martin, Rebecca, thank you very, very much for spending the hour with me. It was very enlightening and lots of learning for myself and the listeners. So thank you.
Thanks, Ryan.
Thank you for having me.